This last example that we're going to work from the book doesn't give us some of the information we're used to. This is actually about a proportion, and so it won't have a mean, and it doesn't have a standard deviation either of the sample or of the population, and so we can't use the z-test or the t-test. So I'm going to show you how to do this on the calculator, but I'm going to walk through the way the book goes through, talking about how to do it with formulas that we have had, and using some calculator to solve those formulas. But there is a shortcut that I want to show you. So this problem is about June believes that 50% of first-time brides in the United States are younger than their grooms. So she performs a hypothesis test to determine if the percentage is the same or different from 50%. So she's sampling 100 brides, and 53 reply that they are younger than their grooms. So this is the hypothesis test. She's using a 1% level of significance. Now, unlike our other tests, this is going to be a two-tailed test because she's trying to determine if it is different than, right? So it might be higher, it might be lower. Something like this is what we're looking at, and we have our mean here. So we're looking at a percentage problem and wondering if it's going to be different than. So it means it's a two-tailed test, which is a little bit different than what we have done so far. So knowing that, let's go ahead and see if I can make all these little different pieces work. Just pulling up and discussing it before we look at the calculator solution. So in this hypothesis test, the level of significance is 0.01. Now, because it's a two-tailed test, I'm going to have half of that 1% in one tail and half in the other, okay? So that is where I get that 0.05. I'm doing half of it for the level of significance. And I will show a little picture of that later too. But that's because of the words is the same or is different. I'm trying to prove. So my null hypothesis will have an equal sign, and the alternate hypothesis will have the not equal sign. I don't care if it's bigger or littler. I'm just looking to see that it's not the same. So that's how I set up the hypothesis. The random variable p prime is the percent of first-time brides who are younger than their grooms. And so we're going to perform this distribution for the test. So the problem doesn't have a mean. The information is given in percentages. So we're going to use that distribution for p prime with the estimated proportion that we did. I think it was the same week that we did the binomial distribution theorem, where we're actually going to take, maybe it was when we were doing probabilities, not really sure. Where we're going to take p, which is the probability underneath here, which is 0.5, and the probability that it's not. These are equal, so it's going to be 0.5 minus 0.5 over 100, and I will take the square root of that. And that is what I would enter into my normal distribution to get what my p is. My p-value is right here. And where x is 53, because that's how many responded that they were younger. So this is really the sample size that I'm kind of looking at, my p-value divided by the sample size. So that's how we look at it on the when we are doing it a little bit more by hand, although it does use the calculator to discover the p. But I want to look at the picture and how we interpret it, and then I'm going to go to the calculator. So the interpretation of this p-value, if the null hypothesis is true, there is a 0.5485, that's our p-value we discovered, probability that the sample proportion is 53 or more, or 47 or less. See, we have the middle of 50. If we're talking about 53, we have to go down to 47. So we're in that range. And we're talking about the tails. So it's 0.27, half, remember, of the p-value is in the tails. 0.274 in the first, and same in the last. So that is what this graph looks like, and I think it's very helpful to have the graph to explain it. So here we have that mu equals p, which equals 0.5, and it comes from our null hypothesis. P prime is 53. Since it's a symmetrical curve, it's two-tailed, and we have equal distance here. We added 3 and we subtracted 3, and we discovered what is the area under the curve. So now we get to make a decision. Since our level of significance, 0.01, is less than our p-value, which was 0.54, we cannot reject. There's not enough difference there between the 53 and the 50 to say that we have more than 50% of the brides that are going to be younger than their grooms. So that's how we work that with the level of significance, and that's how we form our conclusion. I'm going to go back to the problem that is listed, and let's bring up our calculator and see what to do here. Okay, so I have to make sure my calculator's on. It goes to sleep. I'm going to go to the stats menu and over to tests. But this isn't a z-test or a t-test because I don't have a mean and I don't have standard deviation. I'm going to go down to the one proportion test. I'm going to click on that. Okay, maybe I have to scroll down on this one. This is not my normal calculator. And so what is my probability that I'm given, or proportion? Is 0.5, right? That's the number that I'm starting with. That's in my null hypothesis. My X, I actually had 53 respond that yes, they were. And N, I surveyed 100 people. So then this next area is where I'm going to leave this highlighted because my alternate hypothesis had the not equal to. That will give me the two-tailed test. This one would be for less than, or this one would be for greater than. So this one is correct. So I'm going to go ahead and click that and move down. And I want to calculate this. I am going to come back and draw it just so you can see how fancy this is. And when I enter this, I get that same number. There's my p-value right there. Okay, and a z-score of 0.6. So it calculates all of that for you. And feel free to use the calculator. I think it's a marvelous thing. I'm going to go back to the same test. My data should be in there. Down to the proportion test. And this time when I come through here, I'm going to draw it. Make sure there's nothing else in your Y editor and that your graph allows it to be drawn this way. And this shows me, okay, it is that two-tailed test. What I'm looking at is the area under the curve. Okay, and this number here, this p-value, is the actual number if I add both of those together. So if I split that in half, that is the area under one side and under the other side. And it actually gives me my z-score right there as well. So this conclusion that you can draw just from these, just from doing it on the calculator, I would go back to the same part where I was drawing my conclusion before and draw my conclusion. The level of significance that I was given is 0.01. My p-value, which I got on the calculator, is 0.5485, which is larger. Since it is larger, the p-value is larger than my significance level, I cannot reject the null hypothesis. So that's how you would use a calculator for this particular type of problem. Hopefully that made some sense. I know I had a lot of moving parts here and hope you were able to grasp what I was trying to show you. Let me know if you have some questions. Thank you.